And so far, so good. Most of you are doing well. I don't have an average of the scores yet, but I think on overall, most of you are doing well. I did print the homework, so at the end of the lecture, I will pass the homework. And for today, what we're gonna be doing today is just you already know how to solve LP programs using the graph method and also using the simplex algorithm. Today, I'm going to show you how to solve these LP problems using the computer. Specifically, we're going to be using Excel, the solver in Excel, to, um, to implement these programs and also to get a solution using Excel. So Excel is not the only software or the only package available for solving LP problems, but I tend to use Excel because it's one of the software that is mostly available. So you will work for any company, most of the companies will have Excel. So you'll be able to solve your programs using Excel. So the lecture for today, this is lecture number 6, and it's solving LP using computers. And your textbook has a section devoted to explain how to use Excel. Also, I don't know if they go in detail. There's another software that they explain, but we're going to focus for the purpose of this class on Excel. So the introduction, I'm basically going to tell you a little bit about how to use Excel to solve these programs. Then we're going to go and set up a spreadsheet for a specific problem, which is the Petas Inc. problem that we already saw in class. And then we're going to get a solution for that problem. After that, I'm going to ask you to work independently on the problem, on the lab, and you'll be programming that particular problem individually. You're going to upload your spreadsheet to Tracks, and you're also going to submit your answer. So it's very important that you pay attention to what we're going to be doing in this lecture. Okay, so we're going to use Excel to solve linear programs, and the recommended readings is 2.3.1 in your textbook. So as an introduction, Excel has the capability to solve linear problems, and in this lecture, I'm going to show you how to use the solver. How many of you have used the solver before? Anyone? No? Okay, so good. So you're going to learn about this capability of Excel. The key to solving an LP on a spreadsheet is to set up the spreadsheet that tracks everything of interest. So if you have cost, profit, if you have some constraints, you have to list those in your spreadsheet, and you're going to be using that information to set up your program. So how to set up the spreadsheet? Identify the cells of interest that can be varied. These are called the changing cells. Most of the time, these changing cells are going to be your decision variables. Okay, so those are the cells that are going to be changing. And most of the time, that's going to give you the solution. So the changing cell is going to give you the value for each decision variable. Identify the cells that contain the objective function as your target cell. So you're going to have a cell, an independent cell that is going to contain your objective function. And once you solve the problem, the objective value will be displayed on that cell. And lastly, we have to identify the constraints and tell the solver to solve the problem. So at this point, the optimal solution will be placed in the spreadsheet, and the optimal solution will be the objective value function and the decisions for the changing cells, which are the decision values. Okay, so let's go back and review these problems. So remember these problems? This is the first LP we discussed in class. You have two different products, and you want to decide how many of each you're going to produce. Specifically, you have trains and soldiers. You have profit that you make for selling each type of product. So for selling it sold here, you get $27. But you also spend $10 of raw materials, and also you have a variable labor cost of $14. And to build the soldier, you require 2 hours of finishing labor and 1 hour of carpentry. And you have the same requirement. Actually, you have only 1 hour of finishing labor for the trains and 1 hour for carpentry. But you can sell a train for $21. You have $9 of raw materials and $10 of variable labor cost. So that's the information for each type of truck. You also have the constraints in terms of the raw material that you have available, and also you have the constraints in terms of the capacity that you have to build these products. So you have 100 finishing hours and 80 carpentry hours. And also you know that the demand for trains is unlimited, and at most 40 soldiers are bought each week. So we want to maximize our weekly profit, which is the difference between the revenues and the expenses. And we were able to formulate the problem. So we have 4 constraints. One, the objective function is to maximize the profit. And we have 2 constraints for the non-negativity conditions of your decision variables. So you want those decision variables to be at least 0. Okay, so you remember this problem. Then we solved this problem using the graphical method. If you remember, we used the graphical method, so we plot the constraints, and we were able to identify the feasible region. And we also draw those isotropic lines to identify our optimal solution, which is this point right here, where x1 equals 20 and x2 equals 60, giving you an optimal solution of 180 in terms of profit. Okay, so you remember how to solve the problem. You were basically plotting those constraints, finding the feasible region, and finding the optimal solution. Now we want to try to solve the same problem using Excel, and you will see that you will get the same optimal solution. Okay? So that's why I wanted to use this problem, because you already know the solution for the problem, and you'll be seeing that the solution that you will get using Excel is the same. So let's walk you through this example, and then we're gonna actually implement the example in the computer. Okay, so I just want you to see the process, then we're gonna do it step by step using the computer. Okay, so to begin to create, you need to create a table with your problem information. So this is just a suggestion that I made. You can create a table with the data of the problem, and then you can identify your changing cells, which are your variables. So in this problem, you only have 2 variables, x1 and x2. Identify your target cell, which is your objective function, and have an independent cell for your target. And then you can have a group of cells for each constraint. So for example, in our problem, we have 3 constraints. So I'm using a table for the constraints, and I'm identifying each constraint, 1, 2, and 3. And you'll see what values you will insert in these cells. But you know that each constraint will have a less than or equal value. And you already know the right-hand side of those constraints. Okay, so the only part that you're going to be editing from this table is your objective function. So you need to insert a formula for your objective function. In your formula, you already know that formula is 3x1 plus 2x2. So we're going to code that in this cell, and we're going to code the constraint left-hand side. So we're going to insert for constraint number 1, 2x1 plus x2, and so on. Okay, so we're going to be dealing with this type of problem or table when you are trying to solve a problem using Excel. So you need to create your table, and then you know that you're going to have these 3 variables, changing cells, target cell, and your constraint. Okay. The good thing about having the information in a table form is that once you code your program in Excel, if you change the values of the table, you can easily find a solution for a different problem. So for example, you have your code for your program, and you want to change the selling price to $30 in Excel, you can change it and solve the problem one more time and see if the optimal solution changes. Okay? So for now, let's just focus on how to code the program. Okay, so let's solve a solution. Again, this is our linear program, and this is our table. So the first thing you have to do is to set up your objective function in Excel. Okay? So how many of you have experience with formulas in Excel? Okay. So if you don't follow, just let me know. So what I'm going to do is just try to type or use a formula to type this objective function. So the objective function is just because right now we have the objective function in simplify. So the first part is just 27 minus 14 minus 10 times x1 plus 21 minus 10 minus 9 x2. And you see why, right? Because you're making a profit of 27, but you have the cost of 14 and a variable cost of 10 for the sold here. So your final profit is 27 minus 14 minus 10, which is 3. And the same thing for the trade. Okay, so what I'm trying to code in this cell is just this formula. So I have B2, so it's column B, selling price is in row 2, so 27 is B2 minus B3 minus B4, so that's this part, times X1, so X1 is this cell, is B9, times B9, plus C2 minus C3 minus C4, right here is this part, 21 minus 10 minus 9, times C9, which is X2, C9 is this cell. Okay, so the formula that you will have in here is this one, okay? And this is representing the objective function, the original objective function. Right now it is equal to 0. Once you insert this formula, it's going to be equal to 0 because you have no values for your decision variable. So your decision variables right now are 0, so when you plug in 0 and 0 here, your objective function is 0. Any questions? Okay, so this is the formula for this cell, which is your objective function, and it's representing this part here. Okay, so now we're going to do, actually we're going to do the same thing for the constraints. So now we need to code this cell, and this cell for the constraints. So let's move to the first constraint. The first constraint is just 2x1 plus x2. So, okay, so we have B5 is the finishing labor hours for x1, which is the soldiers. So x1 times 2, so it's B5 times B9. And then we have the finishing constraint corresponding to x2, which is the train. So we have B9 times C5. C5 times C9. And this is going to become clear when we actually work in the Excel spreadsheet. But I just want you to give you an idea of what we're going to do. So we're coding the constraint. So again, we're using the values from the table and the values from the variables to code these left-hand side of the finishing constraint. We do the same thing for the carpentry constraint. So in this case, you have x1 plus x2. So again, you multiply the carpentry constraint b6 times b9, this part, plus c9 times 6, right here. And the last one is just x1 less than or equal than 40. So you just have to put the value of the cell corresponding to x1, which is b9. Any questions? So if you're familiar on how to write formulas in Excel, that's what you need to do here. Just write the formula corresponding to each constraint, write the formula corresponding to each objective function. Then, once you have your formulas in the table, the last part is just to tell the solver to solve the problem. Okay, so now we have the constraints. Actually, you'll see that you also have to add a constraint for the non-negativity constraint. So you have to add x1 being greater than 0, x2 being greater than 0, greater or equal to 0. Okay, so this is a table you will need. Now, from the data tab, select the solver. So we're going to go to the data tab and find solver in the analysis options. Solver is right here. But sometimes if you're using the solver for the first time in the computer that you are using, sometimes the solver is not installed. So if that is the case, then you're going to have to go install the solver add-in. The way you install that is you need to go to the File tab. So you're going to go to the File tab and click Options. Then from there, you're going to go to this option menu and you're going to select Add-ins. And the Add-ins option is going to show you this table. Right now, you see the Analysis Toolpack and the Solver add-in are already installed. But if that's not the case, then you're going to have to find those tools here in this list and tell the Excel to install them. Then it's very easy. Just click on it and tell install. Okay? But if you don't see it in your computer, this is what you need to do. You go to File, Options, click Add-ins, and install these two. And this is Toolpack and Solver add-in. Okay? Now, using the table we have, from the Data tab, select the solver. So I'm going back here. So let's say you have the solver installed already. You're going to click here, solver, and then you'll see this menu or window, and that's the window that is going to allow you to use the solver. So this is the window for the solver, and in here you're going to insert the parameters for the LP. So the first thing that the solver is going to ask for is the objective function. That's the first line. So you're going to tell the solver where your objective function is. So from here, you know that the objective function is in this cell. So you're going to add that reference, B11, to that first line. The easiest way to do that is just clicking here and then click on the cell that will insert the correct cell in your first one. Okay? Now, depending on the type of problem that you want to solve, you need to specify if this is a max or minimization problem. In our case, we are trying to maximize the profit. So just click max and you're done with the objective function. That's all you need to do. Okay, so you just select the cell in which the objective function is, and then tell the solver if you are trying to maximize or minimize the problem. Then we need to set up the decision variables. Okay, so the decision variable cells need to be inserted in this line here. So this is by changing variable cells. So again, just have to tell the solver where those variables are. So you can hit this box and select these two variables, so B9 and C9, and those are going to be displayed in your variables. Okay, and that's to set up the variable. So you will tell the solver where your variables are. And the fourth step is to set up the constraints. So the constraints, it involves more work, but it's not difficult. You just have to fill this box right here. So what you're going to do is first click add. Every time you click add, it's because you're going to add a constraint. So once you hit add, this box is going to show up. And this box is just to add a constraint. So the box is set up in such a way that basically you insert the left-hand side of the constraint in this box, then you specify the sign of the constraint, and then you insert the right-hand side. So it's very obvious, easy to use. So for the cell preference, let's start with the first constraint. So our first constraint is this one, 2x1 plus x2 less than 100. So you know your first constraint is this row. So you're going to use this cell preference just to tell the solver to use this cell. You know your constraint is less than or equal, so that stays the same. And then your right-hand side is just this value right here. Okay, so insert left-hand side, their sign, and the right-hand side for the first constraint. And then if you need to add another constraint, just hit add to enter the next constraint. You'll do the same thing. You will go here. You'll find the cell corresponding to the left-hand side for the first constraint and the cell corresponding to the right-hand side, and click add again because you have one more constraint to add, which is the last one. So again, same process. Click add. Okay, so this is what I was telling you. You have three constraints, but you also need to tell the solver that you want those variables to be greater or equal to 0. You don't want negative values for your decision value. So you need to set up the sign restrictions for each variable. So we have two variables, the x1 and x2, which are located in B9 and C9. So I'm going to tell the solver the decision variable x1 is greater or equal to 0. And hit that. And the decision variable x2 is always greater or equal to 0. And since that is my last constraint, I hit OK. And you'll see that your constraints are going to show up now here. See? Yes.
What's that little box like right in there? It says
This one?
make unconstrained variables non-negative.
Yeah, I guess you can also use that in order to tell the solver that you don't want your decision variables to be negative. Okay, so that's the new. I was used to use the older version of Excel, so I think this is new. So instead of adding the constraints for the non-negativity of the constraints, like x1 being greater than 0, you can leave that, or you don't have to do that. Just click here, make unconstrained variables non-negative. That will make your variables always 0, greater or equal to 0. Okay? And we can test that in the example. But thank you, yes, that's true. This should spark. Okay? So now you have to specify the solving method. So in this class, we are focusing on using the simplex algorithm, and that's what I need you to use in this select solving method. So we're going to use the simplex LP. So you have to pull this menu and select the simplex LP, and then you hit solve. And this is what you're going to see. The solver results. Solver is going to give you a window that is going to ask you if you want to keep your solver solution or if you want to restore the original values. Also, it's going to give you a report. So for now, I just want you to keep the solution. The solution is going to be displayed here in your table. You see the objective function value is now 180, which is what we got with the graphical method. And also the values are listed in your Excel spreadsheet. Okay, so you have the value of x1 is 20, x2 is 60. So keep the solution, hit OK. You have your objective function values, and also you have your decision variables values. Okay? So that's what we're going to do now in the computer, so you can log in your computers. And let's work on this problem. Also, you can go to tracks. I already have the Excel table available, so you can download the table, and we can just go ahead and program the constraints in the solver. Let's try to get in the network. It is lectures. Yes, the lectures. You will see the spreadsheet there. Just let me know if you're ready. You might need to save it somewhere in your drive. Okay, so everybody's ready? Okay, so you have already the table, you have the information. So we're going to start by working with the objective function. So again, the objective function is just 3x2 plus 2x2. In this case, I'm going to program the whole thing. So this is going to be equal to the first part of the objective function is for the solve year. So you have the revenue or the selling price is B2. So first thing is, in order to insert a formula, you need to start with the equal sign. Then open the parentheses. B2 is the selling price minus the raw material cost, which is B3, minus the variable cost, which is B4. And you can close that parenthesis and then multiply that times your decision variable x1. So x1, it is in cell B9. So that's the first part of your objective function. So you are looking at the difference of the selling price and the cost and multiplying that times your decision variable. Questions? Now we're going to do the same for the trains. So you're going to add plus, again I'm going to use a parenthesis here, and I'm going to start with the selling price for the train minus the raw material cost for the train minus the variable cost for the train. And all that is multiplied times your x2. Okay, so we have the same formula that we have on the slide. So it's difference here, selling price minus raw material minus variable cost times your first decision variable plus this difference times your second decision variable. Any questions? Okay, so that's your objective function. And it should be 0. First constraint is 2x1 plus x2. So we have equal. This is the constraint for the finishing constraint. So we're going to use 2, which is B5, times x1, which is B9, plus the train finishing labor hours, which is C5, times x2. Questions? So it's B5 times B9, finishing labor hours, B5 times B9 plus C5 times C9. And that has to be less than or equal than 800. Okay, so hit enter. That should be 0. Now we're going to enter the carpentry constraint. So this is equal to B6 times your x1, which is B9, plus C6 times C9. Again, carpentry constraint. These are the coefficients for those constraints, or for the constraint of carpentry. These are the coefficients. So you're multiplying those coefficients times the decision variable. Questions? Okay, so hit enter. And we have one more. The last one is just demand for salt years, and we know that the demand has to be less than 40. In that cell, you just have to input the cell for the decision variable x1. So x1 needs to be less than or equal to 40. So it's just B9. Okay, so hit enter. Something that you can do just to get familiar with the spreadsheet and see what type of solutions are feasible for your problem is you can input any number here in your x1 and x2. So let's put 1 and 1. You'll see that now you can identify that solution, x1 equals 1, x2 equals 1 is feasible. Yes, it is feasible because it satisfies the constraint. 3 is less than 100, 2 is less than 80, and 1 is less than or equal to 40. Okay? So that's always good. That's always good to have an spreadsheet. You can check your solution. But just leave those cells empty for now. And now let's go and try to use the solver. So again, trying to follow the same steps that I showed you in class. So go to the data tab and find the solver. And let me know if you have the solver installed.
If we don't, where do we go again?
Okay, so if you don't have the solver, you go back to your file tab and click options.
Oh.
So click there, you will see this window. Go to add-ins and here you will have a inactive application add-ins. Find the solver add-in. Just say something. Gonna install one here. And then okay, so forgot to tell you about the whole process. So go to options, add-ins, select the solver add-in and hit go. There you will have add-ins available. Hit that one, solver add-in, and click OK. Were you able to install it? Okay, good. So if you go now to the data, you should have the options here. Click solver and you will see this window. Okay, so now we're going to input our objective function, our decision variables, and also our constraints. So we're going to start with our objective. So set the objective. Again, the easiest way is just to click in this box, in this corner, click that box, and select the cell corresponding to your target cell. In this case, it's B11, sorry. So click there and hit enter. You'll see your cell in that line. Now, you need to select what type of objective function you want to use. So this is a maximization problem, so that stays the same. So that covers the objective function. Now we need to specify our decision variables. So by changing variable cells, again, I'm going to use this box. Click. You can select both variables at the same time and then hit enter. So you should have B9 and T9. That is for the decision variables. Now let's add the constraints. So this is easy now. So click add. For the first constraint, you have B14, sorry, B14. So click this box for the left hand side and click here, which is your left hand side for the first constraint. This part here, you'll see that you have many options. For now, we're just keeping the problem with less than or equal. But if you need a constraint that is equal, you can have that constraint. If you need a constraint that is greater or equal, you can also do that. And your left hand side and your right hand side is just this cell here. Click add. Then go to the second constraint. Same process. 80. Click add. And then go to the last constraint. And click OK. So those should be your constraints. You have 3 constraints now. I'm not doing the negative constraints for the decision variables because I'm going to test this. So if that works, then you save some time. You can just tell the program from here that you want the decision variables to be positive or 0. Now you need to select your algorithm. So you'll see here that you have 3 options. Since we are working with LP problems, you're going to use the simplex for linear program. But this algorithm is, you're probably going to see this in your advanced operation research course, in which you see, instead of looking at linear programs, you will see nonlinear programs. For that type of problems, this will work. And you also have some heuristics in case you have problems in which you cannot find the optimal solution because they're too big or too complex. There's always heuristics that will not give you the optimal, the best solution, but will give you a good solution for your problem. And those are more advanced topics that you will see later in your coursework. But for now, let's just focus on the simplex for LP. And hit solve. So this is the window I was talking about. So if you move that window right now, you'll see that you have your objective function. The optimal solution is 180, and you have your decision variables already listed. Everyone was able to get the solution? Okay. Any questions? So again, you can modify these parameters, try to solve the problem different, and see how those decisions change with that spreadsheet. So now, what I want you to do is to practice on your own. I'm going to give you a problem. So let me hit here, okay. And see if you have any difficulties. So again, you'll be working on your own. This is not, this problem doesn't have a statement, formal statement. It's just an LP in formulation form. But the process still applies. I didn't want you to formulate and also solve, so I gave you the formulation. And let me see if you can figure out how to establish the table and also how to get the solution for that problem. As I mentioned earlier, I want you to upload your cell file to Tracks. So there's an assignment option in our webpage. You can go to that option in Tracks and you'll see that there's a link there to upload your cell file. Yeah, questions? You can ask questions. Just creating this table just to give you an idea of how you can set up your table.